Thank you, everybody. My name is Chrystian Vieyra. I am an engineering manager. I am going to be talking to you today about pruning your app, good practices for reducing your app size. Before we talked about deep links, let me tell you a little bit about the Xfinity app. I work on the Xfinity app, and it's the one-stop shop for all Xfinity experiences. You can activate your gateway, you can activate your security system, monitor all of that, and my personal favorite feature is using the cameras, because I can always take a look when I'm traveling or I'm in the office. I can take a look at my cats, what they're doing, all their adventures. So yes, please check the app. So I'm going to be talking about how to make your app smaller. And here's a little overview of what we will discuss. I'm going to give you a rationale why reducing your app size is important. We're going to talk about using lossless compression for image formats. We're going to talk about how to compress the code and the resources in your app. We're going to talk about using amazing features from Google Play, like Play Feature Delivery, to provide your users for the things they need when they need them. And monitoring, how we can continue tracking the app size over time. I looked at many studies regarding app size and their impact on install rates, and I found this wonderful study from about 5 years ago from Segment. And they realized that smaller APK sizes correlate strongly with higher install conversion rates. They purchased an app called Mortgage Calculator, and in this app, they artificially increased the size to measure conversions for installs. And for each megabyte, they saw a linear decrease of downloads when they went from 3 megabytes to 99 megabytes. So users clearly care about app size when downloading the app. Another study comes from Google. The Google Play developer team did this thing about 5 years ago, and they found very similar things. Download completion rate of APKs, it's much smaller the larger it becomes, right? When the APK size was around 10 megabytes, it was 30% higher, the completion of downloads, versus a 100 megabyte binary. It makes sense. Your connection might time out. You might not have the patience to wait for the entire download, and you cancel it. They also found, interestingly, that the reduction in downloads is very correlated with the market. So for instance, here in the United States, I have a device with 512 gigabytes of storage, a foldable device. A lot of people around the world have much smaller storage sizes, right? You're talking maybe 8, 16, 32 gigabytes, and with a few videos, a couple shows you download there's not a lot of space. And yes, so there's studies noticed that in India, Brazil, developing markets, it's far more important having a smaller download size there. It has a bigger impact than here. I also took a look at how our app sizes have been growing over time. And this study comes from Sensor Tower. And Sensor Tower found studied over time how apps have been growing in size. And as you can see, Gmail app, this is iOS. I couldn't find an Android chart. But on iOS, the Gmail app has grown 19 times since 2016. And it makes sense. We're constantly adding new features to our apps, and the apps keep growing and growing, right? So we have to find a balance of how to keep providing features, improving our product without increasing massively our app size. The Manifest, I found this other thing. The Manifest did a study asking people, why do you delete apps? And the 3 top reasons were, the first reason, app wasn't used. Makes sense. The second one, app didn't fulfill needs. The app wasn't what you expected it to be, so you uninstall it. But the third reason was the lack of phone storage space. I know Apple used to have, I think Google used to have this advertisement on TV, like how iPhones, you get the iCloud warning message when you're trying to take a picture, like, storage full or your iCloud storage full. It kind of makes me think of this, right? Users have that anxiety of not having space, and they might remove your app if they are having that anxiety and if they see the size of your app is very large. Finally, with this rationale, I wanted to talk about something that is often overlooked, because we talked about app size, but our app has two different sizes. So if you go to the Play Store and you install your app, the first number, the number you see there is the download size, because your app is distributed as an APK or an app bundle, which is kind of the same thing. It's already compressed. An APK is just a zip file, essentially. It might have some additional metadata, but it's a zip file. So what you're downloading is already compressed. So by the time you install it into your device, your size will probably increase. And here's a little chart. Here's the Xfinity app. In the previous chart, the previous image, the app size was around 90 megabytes to download. Once you install it into your device, it's about more than twice as much. And that comes from the app size. Your app got uncompressed, the assets, so it went from 90 to around 188 megabytes, because it's no longer a zip file. Your user data, as your users are creating items, they're taking pictures in your app, you're saving an internal database about your user. That increases the size. Also, caching. Just like on web browsers, like your cookies and crashing like that, there is caching also on your app, right, to optimize ways your app works. So that's essentially it, right? That's the rationale. There's a lot of studies talk about app size being very important. So I've been very passionate about this. And I started working on the Xfinity app on ways to change this. And the biggest culprit of app size for us was images. And we were using PNGs for our assets, which I think is the standard many years ago. So Google came up with an open source format called WebP. It's compatible with PNG assets, so you can compress a bitmap or PNG into WebP. And on average, lossless compression, meaning nothing is lost, you will end up with around 26% smaller file, right? So if you have an image, 26% on average smaller. Some cases, it's much better. WebP supports lossless and lossy. Lossless, no data is lost. Lossy, some data will be lost, right? So some colors, maybe some blurriness on your image. And Android has had support since Android 4, so for many, many years. WebP does have some downsides. I face this because our developer team our design team uses Figma, and Figma does not natively export to WebP, right? So the assets they generate are in bitmap, PNG, and they have to convert them, right? So there's that additional step. And your design team might be ambivalent or reluctant to try to change their workflows to add an additional plugin. I think the biggest challenge is that iOS does not natively support WebP. So you cannot use the same format across both platforms. On iOS, a lot of people use HEIC, but that format has some challenges. It's not as straightforward as WebP. And some services, right, Adobe DAM or some CDN services where you might be hosting those files do not currently support WebP. Here's the scenario we had in WebP, in Xfinity. So we had this image of a woman with a camera, one of our products. It was hard-coded in the app, and the original image was 1.6 megabytes. And within the app, it wasn't even a hero image, right? It wasn't huge. And it was 1.6 megabytes. So I took it upon myself, and I compressed this file using lossless compression, and that yielded me 46% reduction. So from 1.6 megabytes to 830, right? Almost half, right? And that was just lossless compression, no changes. And then I started applying lossy compression, losing a little bit of quality in the image. And by applying 80% encoding quality, so around 20% data was lost, the file became 3% the size of the original. So from 1.6 megabytes to 48 kilobytes. I couldn't see any difference. The design team couldn't see any difference, so it was approved, and we added it to the app, right, that change. And it was trivial. It was trivial, and I'll show you how you can do that too. Here's on Android Studio. You can launch Android Studio, click on any drawable file, any image you have there, right-click on it, go to Convert to WebP, and then you get a little dialog that I showed there, that it shows you the options, lossy or lossless. And again, lossless, nothing is lost. And a cool tip I learned as I was compressing the app, you can grab the whole drawables folder. So you don't need to grab every asset. You can just grab the drawables folder, right-click on it, and batch convert, right? And then the output of it is Android Studio gives you a little widget, like a toast message on the top, on the bottom right corner, tells you 10 megabytes saved. It can be a little bit deceiving because you are doing it on your project, and you are compressing, if you're doing that, you're compressing all assets for all resolutions. XX, HDP, HDPI, and all of that, right? Like 5 different assets. So what your users get, the binary your users get only has, because most of us are using app bundles, they only get the assets for the specific resolution and type of device you have, right? So the number that Android Studio will give you will be deceiving because it's counting all other resolutions. So it look big, huge. So it'd be maybe a third of that. And here's a little example. I have a video of how I went around and I compressed the file. You can see here's the little prompt that you see in Android Studio. You see your original image, the WebP image, and in the middle, as I am moving the scroll bar, applying additional compression, you can see the resulting image, and in the center, you can see what is being lost. So as I move more and more of the image is lost, but the size becomes significantly smaller. So this is something you can play with, work with your design team on what's a good middle ground if you have some large assets that they're happy with and that you can easily compress. Ideally, though, most of the assets that your users see should not be in your binary. You shouldn't be including a lot of images in your app, right? If you can, you should be using on-demand resources, meaning that they won't be downloaded until your user actually needs them. That will help reduce the app size, right? The app install size that the users see on the Play Store. You can host your images on a CDN, Adobe DAM, or any other services. And you can also use Google Play on-demand delivery, which I'll talk about a little bit ahead. And here's another tip of what you should ideally be using, and that's vector drawables. I think many of us are familiar with them. Here's one that I grabbed from Android Studio directly. The image is what you see on the right, and on the left, you see the code that generates that. So Android drawables are the ideal format. They are incredibly small. And they really represent, as you can see the XML file, they represent directions in XML on how to build that. So it's paths, Bezier curves, right? Just how to draw something. Obviously, that has limitations, but that's the best format. Some of the advantages of that is that it's resolution independent. So with that code, you can expand it, compress it any way you want, and the app size won't increase, right? It's the same size. But the challenge is that it's for simple shapes, icons, right? Not a product image like what I showed of the woman with the camera. That couldn't be replicated. That's a photo. But for other things, it's really, really helpful. It's the best. WebP should be for complex images, screenshots, and photographs. And I'll show you a little bit of the impact we saw in Xfinity when we compress our assets and move them to WebP. So just using lossless compression, we went from a binary size of 92 megabytes to install to 82 megabytes. So savings of over 10%. And that was literally right-clicking on the drawables folder, compress, wait like 30 seconds, and that was it. And because if you're using lossless compression, nothing changes. It's the same image. Meaning if you're using snapshot testing or anything like that, no changes needed. It's the same image. You know, nobody would be able to tell the difference. So you don't need to rewrite any snapshot test. So hopefully you'll start using WebP. or vector drawable. The next part I want to discuss is how to deal with the code. How do we reduce the code size, right? Like your classes and all of that. And for that, we have code shrinkers. Many of you might be familiar if you come from older Android development or Java, ProGuard. ProGuard was heavily used there, and now we use R8. So what are code shrinkers? They are tools to reduce your code size. They remove unnecessary parts of the codes or dead code, right? Code that is not rich. And they also obfuscate. There's some debate if it's real obfuscation or not, but they obfuscate your code. We have two, ProGuard, R8. ProGuard is older, mostly used in Java. R8 was created by Google specifically for Android, so it's more efficient at optimizing Android code. And that's been the default for many years. And with the Gradle plugin 4.0, it's the full mode compression too. So how do you enable this? You go to your Gradle file and you enable minify enable. That's R8, that's ProGuard, right? That will compress your code. You also, ideally, want to use sibling command, I like to say, shrink resources. And I'll talk about shrink resources in a little while. So minify enable, it's R8. And how does it work? It removes code that is never executed. It does class merging. We like to use object-oriented classes and do very fancy code, organize it the way we want. But that might not be the most efficient for code size. So R8 modifies your code and might merge classes together, methods, inline fields, variables, all of that. It does a lot of awesome things for you. There are two modes, full mode and compatibility mode. So if your app currently doesn't have R8 on, you probably don't want to use full mode. And full mode is the default since Gradle plugin 8.0, which came out, I think, in the spring. So you can use compatibility mode. It's a little bit safer mode. It has, and what R8 does is just optimizations for your code, right? And it has risks. So if you don't have R8 enabled and you turn it on, you might experience crashes in your app. And we'll talk in a little bit about why, right? So compatibility mode is the safest one. If you don't have it enabled, start with that and then go to full mode. Now, the next part, I wanted to talk about shrink resources. And shrink resources will remove images, layout files, strings, animations, any asset you have from your build that is not used. It will optimize all of that for you with just one line of code. Another thing that I mentioned before is R8 does obfuscation. So your code will change. The variables, class names, all of that will change. As you can see in the image there, it's just for an example, but all my class names are no longer have readable names. There are things like W5, H8. I cannot read it, right? It's not my class, my calculator, add user, authenticate. I cannot read. So if somebody were to decompile your app, they'll have a harder time to know what is what. Here's a little example, calculator class that I created that prints a greeting. So it has one string, greeting string. I add numbers and I multiply, right? Very basic, computer science 101 class. Once I use R8 on it, the example here, you can see it changes, right? It went from, for instance, calculator to A, right? Because R8 is renaming all your variables for you. So I don't know if many of you are thinking, could this be problematic? And it could be if you're using reflection. Right, and here's a little example again. I have my class, I have field, I have a variable, and I have a method. If I run R8 on it, and I try to call this by reflection, my code will crash. And why? Because if I try to call it like this, calling my class and calling my method, if I applied R8, those names are no longer valid. I'm calling a string, and R8 won't change the contents of a string. Right, so it won't find my method. So if I were to run it and call this class by reflection, I'll hit class not found exception, method not found exception. And this is the typical pattern that you add a new class and you realize you turn on R8 and poof, my app is crashing, right? What do? Often the wrong solution is that people will go to the ProGuard file, ProGuard rules, right? That still has the ProGuard name. It comes from Java. And go to there and add the class that is crashing and add like the class name dot wildcard, right? Because you're like, the whole thing, just don't touch it. So if you do that, yes, your file will remain there, but that has challenges. It kind of defeats the purpose of compressing your code, right? Making your app smaller. Here are a few rules that you can use for that on the program rules. The keep rule is the most common, the one that I use. You do like keep your class name, wildcard, or whatever you want. That class won't be touched and won't change. There are fancier ways to do it. You can do like keep class members. So if there are certain members in this file, you can keep them. So R8 won't touch them. It might touch the rest of the class, but not those members. My favorite is you can do a regular pattern to catch any members, any classes that have certain members. You can prevent it from going through R8. So you can use them. You probably use R8 program rules all the time, but you don't know it, right? So if you bring a library like what probably many of us use, Retrofit, it already includes its own program rules. And as you can see, they use what I mentioned, keep class and keep classes with members. So they do the same. Libraries often already have that created for you, so you don't have to do anything there. And finally, regarding R8, here's a little bit of what you can expect. R8, Google I/O app, open source, Google I/O 2019. Without R8, it was 18 megabytes. With R8 applied, it became 6 megabytes. So, right, just also removing code. And also shrink resources is amazing, because I think what happened here is that that code that was referencing images and assets was removed from R8. So once that happens, shrink resources kicks in, and all of those paths are dead. So nothing is calling those files, so all of them get removed. So that app went from 18 megabytes to 6, 150,000 methods to 45,000, and DEX files, because I think DEX files have a 64,000 member limit, right? Methods you can have on it became just 1. So you can expect amazing things from R8, so I encourage everybody to start using it, and Google has amazing documentation about it. The next area that I mentioned before with images is that you can use Google Play Feature Delivery. This is a service from the PlayCore SDK where you can customize what gets delivered to your user, right? What comes to your device. We have conditional delivery and on-demand delivery. So I'll start with conditional delivery. On Google Play, you can enable conditional delivery to make your app certain app bundles, right? Packages from your app. You can decouple your app. You can have additional packages and target them to specific devices depending on the hardware. Does this device have a camera? Does this have camera support flash? Things like that, right? Does this device have GPS? You can, just like you do in your manifest to filter by devices, you can do by that. And doing that, you can ensure that if a user doesn't support certain features of your app, you don't need to add that to their binary, right? When they go to the Play Store and try to install the app, they only get what they can actually support. So I have a personal use case of this. I have an app that I developed as a hobby. It has a few million downloads on Android and iOS. It's very popular in the developing world. And I needed to add a augmented reality mode. This augmented reality mode used AR Core and a bunch of libraries from Google. And AR Core, at least back then in 2018, wasn't as common in devices that support it, because for a device to support AR Core, it has to go through additional certification from Google. It's additional steps. Not all vendors pay for it, right? So it gets complicated. So I was going to have to add 5 megabytes to the binary size of my app. I think my binary at the time was around 10 megabytes, so I would go from 10 to 15 megabytes. I wanted to keep my app as small as possible because I had a lot of users in the developing world, Latin America. So I used conditional delivery. And with that, it was so simple. I made some modifications to my manifest. I added some rules, and here I'm adding a condition, and the only condition I had was, does the camera support AR, meaning AR Core? And if it did, the additional bundle would be installed at install time. And here's an example. Once I did that, honestly, it's so simple, just as updating your manifest. I did that, I checked on the Play Store, I tested on multiple devices, and you can see that you can open an app bundle that is downloaded, and you can see that the additional, split APKs are not installed and added there. The next feature, it's a little bit fancier, but better. I know many apps. I noticed the Uber app and others use it. I think TikTok do. It's on-demand delivery. And this will reduce also your app install size, but this will cause, opposed to the previous mode that is at install time, this is at runtime. So you're using the app, and for instance, in the Uber app, I see they do it like, suddenly I'm trying to go to an additional feature. I think I saw it transferring to Eats. And then I saw a notice at the top, like Google Play downloading something, right? So they're using on-demand delivery. And with that, if a user, you can make your app really small and only download the things that matter when the user needs it or if the user will ever get there. And the data is downloaded in the background. It's a similar change as the one I showed before on the manifest. And the amazing thing is that you can also monitor via code, and you can see, you can even uninstall it. So for instance, you can have like an onboarding module for a specific sensor or something for your user. Once they go through that, you can delete that, right? So you can have the user download 5 megabytes, activate that, enable that feature, whatever they needed. Once they're done, you can even delete that module. So you can always keep your app size small. So I encourage everybody to look at that. And the final part I'll be discussing now is how you can track the size of your app as time goes on. This is a real challenge, and there's no perfect solutions, right? There's no perfect solutions for this. It's a massive challenge. So you can monitor your CI. You should be using the Android APK analyzer that is included in Android Studio. You can use the Google Play Store and some additional tools you can use. One of the things we have done at Xfinity is monitoring our app size with a simple Gradle script. Sorry, a simple script in our build system, right? And you can read it. It's not very complicated. It just looks at the app size that is generated in our CI, and there's a threshold there. And if it is above that threshold, it fails, and we are warned that there's a problem, right? So we can monitor it that way. If a radical change happens, we can monitor. Google Play has a limit of 150 megabytes for your app bundle. You can go around that limit by using Google Play on-demand delivery to provide your user a larger experience. But that's the limit, right? So we monitor it that way with CI, super simple script. There are some tools. I believe Spotify has this amazing tool called Ruler, and it's a Gradle plugin that generates a report of app size, and also you can add owners. Because if you have like a polyrepo app or somewhere where many squads or teams are working on it, you can assign libraries owners, and you can monitor that change over time, and you add it to your CI, and it generates an awesome HTML page with your changes over time. It's fantastic. Another tool I use is the APK analyzer. That's already included in Android Studio in the tools section, in the build section, analyze APK. You can just provide your binary there and look at the changes. It comes for free, it's amazing. Here's kind of how it looks. It gives you a breakdown of your app change, how your code, resources, what is occupying space. In most apps, you'll see your resources are the things that are occupying the most space. So you can see there and help you figure out what to tackle next. You can also compare two APKs. So you can have your current version and your previous version, compare them, and it shows you the diff, what changed. It's an amazing tool. The next part you can use is using free resources like our Google Play console. There, it gives you helpful hints. You can go there. You can see what your app size download is. You can even add peer apps, right? Your competitors. Google Play will give you a rundown of how do you compare to your peers in app size. One more thing that Google Play provides you is hints, what you can do to improve it. So here, this is my personal app, not the Xfinity app. I want to clarify, because we fixed the images. So on my personal app, I have some PNG images still. So if I go to Google Play, it tells me, it warns me there, you have WebP images, right? And it tells you, make sure to have R8 and all of that. And I feel validation when I looked at it and I see most things, the check mark, right? I know I'm doing things right. So it's a helpful thing. Google Play also records your app size. And you can see there previous app size. You can see monitor your app size, your app growth. This is, again, my personal app. The big jump there is when I was trying to integrate AR mode and all of that. So it's really cool. It's really cool. There are some paid tools that do similar things and some better ways. I got access to a demo of Emerge tools. It's a paid tool. They're often sponsors at DroidCon conferences. I met them in San Francisco, and they showed me their amazing tools. So I was able to feed my APK, and it gave me a rundown of my assets. I blurred because it's Xfinity stuff, but you can see it tells me what changed in an amazing way, right? This is so visually appealing. I can see with the green, the red arrows, and all of that. It's amazing. You can also see a visualization of your package, what constitutes your app size. You can see what libraries. It even flags you, like if you have duplicate assets, it gives you like a little red warning, like a red warning to shame you, right? You have duplicate assets. And you know, when you're trying to get buy-in from people in your company of why it matters to reduce app size, it's easier to show product and other stakeholders visually what the problem is and what can we do to fix it. And finally, you know, Emerge tool shows you amazing tips, very easy, straightforward. It's a paid tool, but I know they offer some demos, so make sure to try it. And finally, I wanted to tell everybody that reducing your app size and keeping it small, it's an ongoing process. It does involve some toil work, right? There's no perfect solution, and it's a matter of getting buy-in from product, because everybody wants, from a product perspective, having a smaller app is a competitive advantage, right? So hopefully you can use that to convince people in your company to make the effort to monitor and to do things like on-demand delivery, compress your assets, work on enabling R8 full mode to get the best out of your app. So with that, that is all. Thank you, everybody, for coming.